Okay, so good morning, afternoon, evening. So it's a pleasure for us to be here in this information session in which we are gonna uh, talk about a new offering from the Artificial Intelligence Finance Institute. We are starting to offer in June a certificate of LMMs, large language models in finance, right? So I will be guiding you through what it's gonna be, all this offering, why it's so important these days, who's involved, and so on. But let me say that this year, when we started seeing the impact, and we are seeing the impact of large language models in different areas of finance, we said, we think that it's a good moment to start building materials, start some sort of trying to put together instructional materials and show practitioners and so computer scientists, quants, finance people, how large language models can be used in finance. So as we're seeing the integration of large language models in finance is revolutionizing the industry, right? The large language models offer new ways to process information, analyze data, interact with customers, create scenarios, generate code, generate text, help on decision making, and so on and so forth, right? So we think this doesn't come with this comes with a lot of challenges, and we will see. Hopefully today you're going to bring home some of the messages, right? And obviously some of the messages are that the integration of large language models in different areas of finance requires often quite a lot of work to make them function correctly, right? And it will more evident in the second part of this talk, right? So we have created an offering, a course that will be then certified. So will be certified that delves into the essentials of LMMs. It's going to be a very practical, right? We over the years, right? Have learned that basically AI in finance, it has to be very practical. So we're going to be very hands-on. We're gonna be distributing on every session several notebooks that will help the students delegate to understand and even obviously implement the different areas of LLMs in finance, from understanding the architecture of LLMs, deploying them for different user cases, right? Like financial analysis, customer service, and so on, right? So we think that it will be essential, right? In a few, I wouldn't say years, but in a few months, training or specific training on large language models, I think will be essential for professionals, not only in finance, but everywhere, right? Okay, so and again, the main difference from this course to other courses that you can see out there is that this is a course that will be some sort of fully devoted to financial applications and the issues and the problems that arise specifically for finance, right? So if we do sentiment, it's a very different user case than if we're doing question answering or doing summarization, or we're trying to build code, or we're trying to build algorithmic trading applications, right? So through a series of hands-on examples and projects, we will learn how to apply LLMs, right, effectively in our sector. And again, I'll be more specific now that we'll go through the table of contents. Table of contents also is a little bit subject to change. I hope you understand that obviously this is a very, very dynamic environment, right? And AIFI, so the institute, it's committed to some sort of update the materials as new things come to us. So the course or the certificate will start on Monday, 10th June 2024, and it's going to start in the form of recordings, right? So we're working hard on the materials as we speak. So we'll make available the recordings in such a way that you can be going through the different materials. Well, depending on your availabilities, depending on your needs, and so on. The duration is going to be on the lectures of 20 hours, right? And in principle, we think 20 hours it's enough to give you or to learn the main areas of application, to learn how LLMs work, how RAG works, retrieval-augmented generation, the different fine-tuning technologies, quantization, sharding, right? And last but not least, obviously, right, agents, which I'm going to speak also about later on, and we think they have some sort of a huge future on finance and everywhere. The instructors, which are going to be more going to go through the bios in a moment. It's going to be me as the head of faculty. Is going to be Hanan Dupuy. Hanan Dupuy, I'm sure you follow her on LinkedIn, and she's sharing lots of really interesting stuff since the beginning of this, so to speak. So obviously, this is a discipline, so to speak, that it's relatively recent, but because I guess that it was after November 2023, with the launch of GPT-4, in which it was started to be evident that this was an exceptionally useful tool, and it could be an exceptionally useful tool again in finance and in many other industries. Then also we'll have Nicole Konigsten, who's also collaborating with our AIFI programs, and David Pacheco Aznar, who's also involved in research with the Institute and also collaborating with other LLM projects. The course, well, here you can see the course fees, $2,000, and we have this super early bird discount, right? So, okay, so let me dig a bit into what we're gonna cover. Again, this is subject to a bit of change because things are going very fast in the space, and obviously we want to be adapting to the recent developments. For example, today we had some Llama 3, right? So almost every day we have a relevant development, a relevant launch of open source model, closed source models, right? And so on. We don't know when GPT-5 is going to be available. We'll try to be updating the materials, the notebooks, etc. Once some sort of this progress with these advancements are available. So how do we split or how do we organize these 20 hours, right? So first we're going to start with LLM foundations to understand, right, one is the LLM, what is the transformer architecture, encoder decoder architectures, right? So basically at the heart of the success, it's we can say that maybe it all started in 2018-17 when transformers in essentially is all that you need from Google started to show that they were exceptionally good at doing many language tasks from Q&A, language generation, and so on and so forth. So we need to spend a little bit of time trying to understand a bit how this architecture transformers works, right? And again, the different architectures that are Lecture 2 is going to be about, a continuation of LMM foundations. Also, we're going to talk about limitations, right? Obviously, right, it's not, as I said before, we have and we see a lot of very interesting user cases, which I'm going to also try to discuss during this session. But also it comes with obviously quite a lot of significant limitations, like knowledge cutoff, domain-specific challenges, solutions like obviously hallucinations, right, and so on and so forth. So alleviating these limitations is obviously part of the work that, let's say, LMM engineers or financial engineers using LMMs should be aware of, and so on, right? Obviously, part of the course is about let's say, conveying the huge discipline that is needed to test these machines, right, in the different contexts. We see quite a lot of let's say, ambiguity when it talks about when people talks about LMMs here in the course. In the certificate, we're going to be very specific about them. So and again, LMM engineers should be very specific, very detail oriented, trying to understand how the model works, how the model can be improved, and so on and so forth. Another thing that I also would like to mention is, right, and we'll have time during the course to talk about that, is obviously the importance of the data set when it comes to obviously the results that you can expect from the LMM and so on, right? Our experience on NLP. So I personally started working in NLP in 2018, right? So quite a long time ago, and the experiences we've been having on different implementations of NLP, right, also are very important. So I think certain NLP experience and knowledge is also needed. And I'm saying all this just to stress again the importance of the data set, right? LMMs don't come with some everything in red, so to speak. So LMMs haven't read 10Ks, 10Qs, annual reports. They haven't read sustainability reports. I haven't read specifically some sort of maybe finance literature that we want them to read, and so on and so forth. So it's also very important that we understand, right, the data set and so on. Okay, then we'll start discussing advanced techniques, right? Like obviously the exploration of zero-shot learning, few-shot learning, right? And the use of prompt engineering, right? By now, prompt engineering is something that I've all heard about, right? And here, right, we have to say that prompt engineering is something that you have to master as an LLM engineer. Sometimes it solves problems, sometimes it'll not be enough, right? So the alleviating or trying to some sort of improve the outcome of the LMM, it's obviously depending on the task, an artist's tasks, and it requires us to understand the essentials and the implementation of prompt engineering, obviously fine-tuning the idea that I specifically train the model again for a specific tasks or subtasks, right, and so on. This is obviously going to be important when what we see on few shot, on zero shot, it's not good enough. Sometimes we see that we want the LMM to be performing a task. Maybe the outcome is not good. So one of the after obviously a diligent exploration of prompt engineering, then we need to also explore technologies, obviously like fine-tuning, right, which we're going to discuss, then on lecture number 4, we will be talking about quantization and sharding, right, and its benefits. We'll also then going to be continuing to talk about a very important session, right, fine-tuning, discussing Chef, LoRa, Q-LoRa, and practical examples, right? Obviously, there's a few ways in which we can try to some sort of make the model work better. One of them is giving it feedback and using reinforcement learning. We also some sort of have a interesting experience in terms of understanding and teaching and training reinforcement learning algorithms. So here, reinforcement learning with human feedback, it's something that has proven to be an important milestone. Maybe probably it's not going to be the last some sort of technology used and so on. But and also then we will start lecture number 5 to talk about retrieval-augmented generation, right? Which I'm going to be talking a bit during the second half of this session. That is going to be a little bit more technical, just to give you a flavor of how the materials and so on is going to be. So our RAG, retrieval-augmented generation, arises when what we want to do, and we want to do that very often, is that also combine the LLM with some sort of a knowledge base, right? So something from our company, right? Or that obviously internal from the company that the LLM hasn't gone through or read, and so on. And RAG is retrieval-augmented generation. There's a set of techniques we can use to try to some sort of make some sort of a machine that it's able to answer questions with the knowledge, with some sort of external knowledge and the writing abilities that the LLM have, but also obviously paying attention to whatever information, internal information, PDFs, Word, Excel files. So it's a very heterogeneous, right? Okay, so how can we solve better some of these tasks? Okay. Obviously, one very important aspect of LLMs is how we evaluate them, right? So we'll discuss evaluation metrics and methods. There's some interesting implementations of papers out there that some sort of help evaluating the element, right? Here we have to say that evaluating the LLMs is just much more difficult to evaluate other supervised learning, some sort of projects in which probably many people in the audience have been exposed to, right, to supervised learning, machine learning projects in which you have a data set, if you have a training set, a test set, and so on, and you have a develop some sort of loss function, right? Okay, so here, or oftentimes in NLP projects, a loss function is something, right, that is much harder to have, right? That's why obviously human feedback is needed in the sense that in the end we need to somehow to say, well, this is a good answer, this is a bad answer, this is an incomplete answer, this is a complete answer, and so on and so forth, right? I have to say too that also yesterday we finished a paper in which we explain a bit several aspects of LLM use, right? In the sense that not all questions are equal, right, for the LLMs, right? Let me explain a bit that. Right? When I'm saying not the questions are equal, I mean that often we can be asking questions to the LLM that can be grounded, right? So that can, for example, if we can be asking questions to LLM saying, okay, what were the revenues of Apple in 2022? And we know that there's an answer, and we know that the answer is in the data set. And we want to make sure that the LLM picks the right number, right, and so on. And it's, consistently doing that for all grounded questions, right? And typically, LLM engineers have been focusing on this some sort of grounded, right? It turns out, obviously, that this is just a subset of things that you can do with LLMs, right? Because in terms of some sort of user cases, right? Quant finance experts, right, are going beyond that, right, and are going beyond that in the sense of asking questions that are not even grounded, right, or questions that are some sort of elaboration of scenarios that never happened, augmenting the data set, and so on and so forth. So I would say that to a certain extent, as a surprise to me or us, right, some advanced users of LLMs in finance, what they are doing is using the LLMs as some sort of a reference of last resort. When things get tricky and I don't have an answer, right, maybe the LLM is going to help me structure better the problem, and so on and so forth, right? Okay, that was a long. Okay, now the lecture 7, and here we're probably going to be modifying a bit we're going to be talking about LLM agents, right? So when I'm saying that we're going to be changing a bit that, it's probably because as we speak, we see a tremendous interest in the use of LLM agents in finance, right? Okay, so LLMs is you use the LLM basically to do a sequence of tasks, right? Until now, we're more used to some sort of discuss specific tasks that you do with LLM, specific question that you ask. This specific question that you ask, maybe it already requires a multi-step prompting, right, to make some sort of the LLM reason to a certain extent, right? But LLM agents will be the next step in the sense that you have some sort of a more elaborated tasks, like maybe oftentimes performed by a human, and you're going to use the LLM and APIs and so on, right, to some sort of be performing a task or sequence of tasks, or let's say a task that requires a sequence of smaller tasks, right? So LLMs, LLM agents, right? And I hope I'm sure that some of you have heard in the or have read in the press, right? So Andrew Ng has been pushing the topic, right, for the last, let's say, a couple of weeks, right? And we do agree that when we're preparing materials for the course, that LLM agents can be some sort of a tremendously useful, right? Because many human complicated tasks that are being performed in financial institutions is humans that some sort of perform a task, evaluate the performance of these tasks, and then they need to do another one, right? I don't know, when they're assessing risk, when they're trying to manage portfolios, and so on and so forth, right? Okay. Now, obviously, LLMs require a lot of work in terms of AI safety, right? So, Nicole, we gave 6 months ago a talk to the ACM members, right? Globally, right? Nicole and I talking about AI safety and the different things that you need to do in order to make, so to speak, the AI reasonably safe, right? Okay, practical examples. So we have a long experience already, right, into looking at financial reports. Financial reports require quite a lot of tweaking with the RAG and so on, right, in order to make it work, right? You go to the LLM, you ask kind of these complex questions, like grounded questions, like what could be the revenues of Caterpillar in the first quarter 2020, right? And again, you can some sort of be asking some sort of less grounding or less grounded questions, like what do you think could be the growth drivers of Caterpillar, for example, right? Okay, again, some things can be grounded, some things are not. And then obviously, right, also sentiment analysis, the use of agents, algorithmic trading. So there's a coding, right? So there's everybody, right, as we speak, is using the LLMs to help, do coding tasks and so on and so forth, right? Okay, lecture 8, we will continue with these practical applications, right? And you'll start, right, working on a real world project, right? So the evaluation of the course is going to be a set of initially a few homework assignments that you're going to need to complete, right? We need to make sure that you guys understand how RAG is done, a little bit of prompting, and so on, right? And then again, that you are able, right, to some sort of perform a real world project. That's not necessarily a big one, but a reasonably small one, and deliver us some sort of a notebook with the outcome, right? So again, the course is meant to be very, very practical. And after the taking these 20 hours, right, and having work on the materials, right. So the idea is that you can be next day in a financial institution or an asset manager, right, in a bank, right, trying to be working in different user cases. Okay, so a little bit of more color on who we are, right? So and that allows me to some sort of talk a bit about also the institute. We founded AIFI or AFI, right? Depending on if you want to pronounce finance or finance, right? In 2018, so 5 years ago, right, when AI wasn't as popular as it is these days, and the idea it was and is to some sort of create courses, right, trainings for financial engineers, for computer scientists, basically in the domain of finance, right? And I personally have more than 20 years experience on finance in banks and asset managers. And I also have an interesting academic experience. So I started to teach at Columbia University in New York in 2012 after getting my PhD. And I taught the first big data in finance course in the United States in 2016. So we have a long so the experience in some sort of introduction of AI algorithms in different domains, in time series, factor models, option pricing, risk, and last but not least, so the introduction and implementation of natural language processing algorithms in finance that some sort of we started with using things like that. I'm sure some people in the audience is familiar, things like TF, the frequency methods, or TF-IDF, and things like that, right? In the faculty, we also have Hanan Dupoy. She's an algorithmic trading in a French bank based in Paris. She has 13 years experience in banking, investment banking, and she's a very hardworking, very smart professional, finance professional, but also very meticulous and attention to detail, right? LLM financial engineers, so to speak. So I think that you probably have seen his wonderful posts on the different, again, implementations of RAG or today with agents in finance. And she's going to be teaching an important part of the course, right, and creating also the materials, right. We're also, by the way, working in some books, right. So there's a question, right? The new optimization system for multi-assets currency. Yes, I mean, we're very open-minded with the projects, right? Obviously, it has to be, as you are, one of the things we're seeing about LLMs is like people is pretty much using them for different stuff. So you're talking about optimization, right? You can also be talking about LLMs doing some sort of supervised learning and supervised learning and so on and so forth, right? So, yeah. Okay. Now, we also have in faculty Nicole Koningsten. Nicole Koningsten is a extraordinary data scientist, quantitative researcher. So she's been working for a number of fintech companies. She's also been in the institute teaching code for our AI5 bootcamp, which is our main offering, is and was a certificate we offer on a broader, right, AI in finance, in which we teach deep learning, we teach machine learning, XGBoost, CatBoost, and SBMs and all that kind of trees and all that kind of stuff, right? And right, and also the reinforcement learning, right, and NLP, right. We again we've been involved in the NLP elaboration of NLP, some sort of products for finance, I would say since the beginning, so to speak, which was 2018. Then we also have in faculty David Pacheco Aznar. He's the chief of AI research at Raven Risk AI, right? So David is currently working in the implementation and application of LLMs in corporate credit risk for the U.S. market, which is another interesting use case for the tool, so to speak, how it can help. Right after reading financial documents, after it knows about finance and so on, to be able to help credit analysts to take decisions about a credit risk about to a company. So he's also been involved in the multiple conferences. We wrote a paper on generative models, but on time series and reinforcement learning. And again, we are finishing a book on AI in finance. Also, I forgot that Nicole, she's been working in a couple of very good publications, Math for Machine Learning, and she's finishing a book on transformers. Transformers, as I said before, are at the heart of all the innovations in NLP, also useful for reinforcement learning and so on. Okay, so this is okay. So questions about the so to speak, a bit the content and the format, right? Okay, good. So, okay, so now I have around 25 minutes to some sort of give you a flavor, right, of the kind of things we're going to be seeing, right, in the course, right? So obviously, again, on the first some sort of sessions, but you know, what is a large language model is designed to understand, generate human-like text. It's built on transformers, allowing them to process vast amounts of data and the intricacies of language, right? And we can use LLMs for text generation, translation, summarization, right? I think there's a question. Oh, you know, no, everything that we are going to be asking, it can be some sort perform in a you know, in a 16 gigabyte some sort of laptop, right? Okay, so we don't need like, okay, like huge. Okay. So the idea is they can do the text generation, translation, summarization, and so on. But I have to say that I think, and the idea is you create an autoregressive machine that it's basically the transformers are giving you are some sort of you prompt. So you give some sort of an input to the model, and you say, what are students doing now, right? And then the LLM has actually built a joint probability distribution of the next word. So it's able to say, out of the 150,000 English words, what is the most likely, what is the more probable word that comes next, right? Okay, this is much more, this is more nuanced than that, because obviously not always the model chooses the word with the highest probability, but depending on the temperature, which is a parameter that you can tune, right, or choose, so to speak, right, you know, then the model might be choosing maybe the second, the third, the fourth word, and some sort of, that's one way in which LLMs, some sort of, you induce creativity to the LLMs, right? When one reads this, it would say, okay, is this really, the outcome of this is really interesting? And I have to say that I think everybody that has been using LLMs for months, at least in finance or research or writing and so on, I think will agree with me that the outcome is surprisingly accurate in terms of it produces, for example, 2 pages of text that are very well written, very well structured, and so on and so forth. So even if some detractors would say that this is just a stochastic parrot, I do think that, as for example, and I agree with Stephen Wolfram, who says that these machines oftentimes do extrapolations, right, that look like very plausible for humans, right? So they're not only stochastic parrots, they're in the sense that they only reproduce things that they have seen in the data set. Actually, as I said before, right, some quants are finding very valuable to be able to discuss things that certainly hasn't been seen in the data set. Okay. For example, what kind of these questions, so what I said before, these non-grounded questions, questions that cannot be grounded because the question I'm asking is something never happened, right? And if it never happened, chances are that in the data set it appears just maybe never or just a couple of times and so on and so forth. For example, right? A recent user case was, okay, how can, what could happen to oil stocks when there's a hyper deflationary environment, right? You see, so something we've never seen, right? Quants and financial engineers are saying it helps me explore scenarios that while while probably the machine hasn't seen anything similar or extraordinarily similar in the data set, the extrapolation that it's producing, the kind of step-by-step reasoning that it's doing makes sense to us, Okay, so I'm not saying that if it's a non-rounded question, the LMM will give you the right answer. Maybe you don't even know what's the right answer, right? For example, again, right, you can ask the LMM what would be what it's going to be the next CEO of Apple, right? And all it can do, the LMM is certainly somehow speculate or extrapolate, do educated guesses or who in some sort of in the universe of Apple, right, could be the next CEO, right, and so on and so forth, right? Okay, so but in order to what we're seeing in what we're seeing in the application of them is that right, you have to be much more precise than we're seeing right now. Right now, what we're seeing is somebody in IT produces a demo with 3 or 4 cases, right, and then this is used as, you know, as a marketing material for the implementation of the MMM in a specific case. Obviously, things need to be much more thoroughly tested, right? So you need to define what actually what it's going to do. Is this a chatbot for internal use? Is this a chatbot for clients? Is this a chatbot to discuss mortgages? Is this a chatbot to discuss when dividends of Microsoft are going to be paid, and so on and so forth? Do the LMM has the some sort of the element has access to information that I want to be grounded, right? Because we know the answer. When is the next payment of dividends of Microsoft, and so on, right? So I think here everybody has been involved in a software development project. So here you need to have some sort of this mindset of things need to be clear, user cases need to be clear, right? Or at least the LMM engineers need to make sure that some sort of there's a specific request or what because you'll see that then you know, it's very important in terms of the RAG that you need to do, the potentially the fine tuning that it needs to be done, the safety and so on that needs to be performed. It can change materially depending on user case or another, depending it's for external use, for internal use. Okay, anyway, so what they can, so LLMs can do for financial institutions a bunch of stuff, sentiment analysis, right, with a bit of caveat, right? So what I'm saying this is because sometimes the LLMs cannot do one shot properly. They need to be tuned for the occasion, right? And today, it's still not clear to me, right, in the 18th April, that you can off the shelf start using LLMs to produce sentiment without being fine-tuned for that, right? But this is an interesting question to ask. Text generation, obviously everybody's using LLMs for text generation. Can you write for me some sort of an explanation of what were Apple's quarterly results? Can you produce a summary for me? Can you reason for me, right? And reasoning and non-grounded questions and so on oftentimes is part of the same universe of user cases, right? When we want to ask a question, right, to the LMM, that probably it requires several steps of reasoning, and it probably can't be grounded, right? And again, the work doesn't finish when we finish RAG, right? Work is not finished when we've done topic modeling. Work is finished when somehow we understand that for the user, for the type of questions that we want to ask the LMM, the outcome is some sort of reasonable. Topic modeling, human-like Q&A, translation, name entity recognition, code generation, API invoking, or agents, right? Okay, so there's a right. Again, more complex tasks are going to require us some sort of producing and some sort of working in an agent. The evaluation metrics, right? So again, if you don't want to be fired on the spot, I always tell my students that data science And NLP is something that if you don't want to be fired on the spot, you cannot, because something unexpected happened to the model, right? And so on, evaluation need to be very thought of. You need to be thinking about all the potential risks that arise when using an LLM for a specific, right? For example, you don't want the LLM to produce harmful, offensive, inappropriate language. This is reasonably easy to some sort of say, don't use these words, don't use these kind of languages, and so on and so forth. The making it perform consistently across diverse inputs, right? Including adversarial questions, right? Noisy, accuracy, reliability, and so on, right? Prediction accuracy, remember that that you will only be able to measure prediction accuracy, right, when you have grounded questions. When you have non-grounded questions, probably the evaluation is going to be much more human, like saying, do I think that the LLM knows what it's talking about? So can I have a conversation of like hyperinflationary environments for US stocks with a machine, and me having the sensation, so to speak, that the machine it's some sort of making the correct some sort of step-by-step reasoning on this. I think this could happen to I don't know, to capital goods stocks, and subsequently this can happen to banks, and so on and so forth. Okay, so also along the way of trying to do NLP tasks, you need to decide, right, if you need LLMs, right? So it turns out that we have to say that not all tasks in 2024, right, need an LLM, right? But you might be using BERT, right? BERT was also somehow a large language model, right? All of us that have been involved in sentiment, we still feel really very comfortable using BERT to do sentiment analysis. You can fine tune easily, you have transparency, you know the weights, and so on and so forth, right? So obviously using, again, right, some sort of open sourced versus closed source is also a decision that has to be taken, considering the user cases, and the privacy and all that kind of stuff. There's some level of consensus saying when we do text generation, when we need to do creative writing or some sort of somehow multi-step reasoning, right? In the sense that, again, asking these questions that require a human or require an LLM to be thinking step by step what could be the consequences of, I don't know, of hiring Caitlin Clark for a WNBA new team, right? I'm sure all basketball on the women NBA managers are thinking about, will she fit in my team, right, or not? So this kind of reasoning and exploration of scenarios, right? LLMs can be useful there, right? Again, right, there's no such thing as a right answer, right? In these things, you cannot ground the answer, but humans that are very skilled can say, I think the machine is knowledgeable in this. I think the machine at least can help me think about the problem and help me around scenarios. Okay, so here in terms of user cases, what we're going to see and we're going to share notebooks is obviously one of the most widely things that come to your mind, right, on the spot, is this idea that let's look at financial reports, right? Can an LLM some sort of look at the financial report of Caterpillar, for example, or JP Morgan, and say, can the LLM summarize? The answer is yes, right? Right. what are the things you need to be paying attention to if you do PDF, if you ingest PDFs and so on. You need to make sure that the RAG is working well, and actually every time that you ask what were the revenues of Caterpillar in 2021, you get the same answer. The answer is correct, right? That at least is making good use of the numbers and correct use of the numbers, right? You can also then, right, again, create all sorts of step, some sort of or step evaluations. You can ask, what do you think about Apple growth in the virtual reality aspect of it, right? And then use that for forecasting and predicting prices and trends, right? Okay, so okay, so that also, so obviously what you might think, you quickly think, oh, I need to build some sort of a trading bot, right, that helps me choose among the universe of stocks and so on, or market outlook insights. So we're going to see examples of these, right, of things that we've built that do a good job, right, when confronted to these kind of questions, right? Other things that can be done, obviously, is we're going to do extensive exploration of the different alternatives that we have in the market. For example, the OpenAI API notebooks, or Gemini Pro API notebooks, replicate notebooks, right? Replicate the use of algorithmic trading, and so on and so forth, using, again, OpenAI, Gemini Pro, or then Llama 2, 3, right? Today it's been the release of Llama 3, Mistral AI, Llama, Claude 3. So another thing that we'll also see in the course is how we can some sort of evaluate. Also, how can we use other LLMs, and we will see more than a little bit more on this on the agent side, right? Some agents are going to be there to evaluate what other agents output, right? So LLMs can also be used to, right? So some sort of evaluate, right? And LLMs can be used to produce, right? Some sort of a data set for another LLM. So here there's really a very interesting set of combinations that can be done in order to gain efficiency, right? Okay, so I haven't used since now the word efficiency, but certainly at the heart of many NLP applications is the efficiency in which you can produce tasks, the efficiency in terms of course, I can write myself a summary of the JP Morgan quarterly report, and it's probably going to be very well written, but I'll probably spend there a couple of hours, while the LLM is going to be able to do that in a matter of 10 seconds, right? So, okay. So efficiency is some sort of, so making LLMs also do checks and balances on the outcome or other LLMs is something also that it can be really, really useful, right? So you can actually do something using OpenAI, but then using Llama 3 to some sort of evaluate. Does this answer make sense? Do you think that the reasons that the Roman Empire fall were these 5, or should we add more? Do you think this is well written or not? Do you think it's something relevant or material missing here, right? So there's a very interesting, okay. Yeah, also, right, we can, using APIs and Python, right, build this idea of the LLM hypothetical answer network, for answer framework, right, that can help us, again, in this universe of maybe less grounded questions, or to do algo trading, and so on and so forth, or help us. Okay. So fine-tuning, we'll explore also fine-tuning, right? Fine-tuning can or should be used when we customize the LMM to a specific domain task or proprietary data. When few-shot learning, it does not give accurate answers, right? So when you see that somehow something is not working, and the few-shot learning, right? Okay, so what's the distinction here, right? The idea is you have grounded questions, right? For example, you're looking at an article about Apple, right? What happens if the machine mistakenly says this is not Apple computer, this is some sort of another thing, right? Okay, so you don't have the few-shot learning is not guaranteed, or the one shot. So the fact that a specific task that you're asking, right, the machine is doing what you wanted it to do, or the machine has the knowledge to do it, and then there's a few alternatives, right? Okay, if your experiments say this is not good enough, right? Again, prompting is one, RAG with some sort of a little bit of more instructions or more knowledge, right? And so on, right? And I would say that the last resort would be fine tuning, and the very last one would be you build your own finance LMM. You shouldn't disregard building your own tools when you think that you have a set of unique knowledge, right? That you have some sort of internal knowledge database is so rich that you think that maybe it's efficient to build right? As I said before, right? In finance and in all domains, right? What the machine has read is essential to the quality of the output, right? And any project should start by saying, right, do I think, or can we test the knowledge that the LLM has in specific domain, right? And again, the example might be sentiment. My current thinking is that maybe you need to pick sentiment and do it in a different way. Use BERT and fine tune BERT, not an LLM, right? Here you're doing a regression, so to speak. You read something and you want a number, right? It's somehow a supervised learning problem, right? Okay, so maybe for some problems you're going to need to go back to supervised learning, so to speak, and give it examples and make sure that the machine has seen the right examples, and so on and so forth. There's also some people that says that along with the machine having read so heterogeneous stuff, right? Like, for example, Christopher Bishop, right, from Microsoft was saying that I think that the machine might be doing some tasks better than supervised learning fine-tuned models, right? But again, this is a a claim that has to be verified in your specific application, right? So to what extent you will improve by some sort of having a closer look at the problem, putting together a data set, and fine-tuning a supervised learning model, right? Or fine-tuning an LMM model, right, for a specific task, right? Okay. So this is other things, right? Yeah. So about tuning the data set and so on, right? Then we'll see RAG, so retrieval-augmented generation using LangChain and so on, right? And let me skip a bit that, right? So we'll see a lot of RAG using LangChain, right? Okay, so sorry for, and maybe let me use 5 minutes to talk about, right, agents, which is something that, again, we think is going to be incredibly valuable to automate tasks in financial institutions, asset managers, everywhere. So the idea, right, of LLM agents, right, is involve LLM application that execute complex tasks using an architecture that combines LLMs with key modules like planning and memory, right? And the LLM serves as the main controller of the brain that controls the flow of operations needed to complete a task or user request, and the LLM may require key modules such as planning, memory, and tool usage. Okay, so this is a bit so again, to a certain extent, right here, what we're saying is that to complete some tasks, right, the agent will be some sort of task to be doing, a specific task about computing things, measuring things, right, doing, and other agents will be being the critics, so to speak. Other agents will be used, right, to evaluate other agents, so to speak, outcome, and say, is this good enough? Do we need to do more work? Do we need to go back, right? And so on. So agents, LLM agents is some sort of agentic is the work that Andrew Ng uses to discuss this whole idea that the next step of probably coding, right, or some sort of automating complicated tasks might be this idea of using LLMs, right, and agent workflows, right? And he recently posted about these ideas of reflection, tool use, planning, and multi-agent collaboration that seems to be at the heart of the emerging interesting implementations of agents, right? And we are working in very exciting materials for the agent session, and I think agents make a very nice case for the projects, right, and so on. So I think. Okay, there's a few questions, but yeah, how do you know the machine has the relevant knowledge, right? Yeah, Andrew makes a good point. I would say the same analogy, right? In the sense that to a certain extent, right, here we're being professors evaluating, right, to what extent the machine is able to answer mathematics questions or biology questions, right? To what extent the machine it's able to, right, it's able to answer a specific questions that it's going to be finding, right, during its use, right? So this is a very also because again, there are emerging properties on the LLMs. I'm not saying LLMs are AGI or anything like that, but certainly agents are extrapolating many times, right? Agents haven't seen, right, haven't seen an hyper deflationary environment in the United States, and still LLMs can help you, right, explore a situation in which say this could what could happen to US stocks in such a case. How can I build some sort of a scenario out of this? Certainly, when you're in a company and you're going to use the LLM to discuss things like, oh, I need to go to a fact sheet of a fund and be able to say what was the alpha created in 2023 and so on and so forth. Again, this trade-off that appears often of grounded questions versus non-grounded questions and so on. Obviously, non-grounded questions, as I said during this presentation, are harder, right, to evaluate, right? But human feedback, yeah, of course, yeah. The machine, yeah, but we also need to educate the machine, so to speak, to say, I have nothing close to that in my data set, right, so to speak. So to some extent, let me say something. Imagine that you're saying, okay, I'm going to ask what's going to be the result of the game playoff, Denver Nuggets. I don't know, Denver Nuggets, Los Angeles Lakers. Obviously, LMM will not be able to tell us, right, the result of such a game, right? The LMM will probably help us in saying ex ante what could be the factors, ex ante what could be the probabilities, right? If we consider what has happened in the season, right, and then and things like that, right? But for other questions that are, you need the answer to be precise, right? You need to make sure that LMM is doing a good job, otherwise you'll be fired, right? For example, if you are asking what is the monthly payment of a mortgage, right? And you want the LMM to be answering these questions, you need to check that the machine is answering with precision, right? Otherwise, you could be found as a bank liable, right, of doing incorrect information. So there's nothing we can take for granted, so to speak. Everything has to be checked, right? But our experience on these several months or more than a year experience of LMM use is that if they have the correct checks and balances, they can be extremely useful to perform a series of from less to more complicated tasks. Again, the one shot, two shots is not guaranteed, in the sense that maybe, again, the extrapolations that the machine is doing on a specific new article you don't think are right, and so on. But this is your job as an LMM finance engineer, so to speak, to find the gaps, to find the flaws, trying to some sort of alleviate them or solve them. If you can't, maybe you have to say, the machine still needs, for example, human supervision before being let alone in the wild. Yeah, of course. Yeah, typically the way you infuse knowledge about specific topic is you do RAG, right, in order to get, right, at least, and in finance this is very, you need to do that because the machine hasn't read 10Ks, 10Qs. Okay, so if there are no more questions, right, yeah, thank you very much for attending this information session. We are at your disposal for any questions you might have, or suggestions, right? Also during the course, right, of things that you haven't seen and you want to see, and so on and so forth. But we're pretty confident that this is going to be, a very good offering for all financial professionals, quants, financial engineers, computer scientists that want to use LMM tools in finance. Also others that don't even know about LMMs and so on. We can, I think, with witnessing an unprecedented interest from all institutions in the planet in some sort of using in different user cases the LMMs for reasons of, obviously, right, of doing better our job, efficiency, speed, and so on. Yeah. Okay. Any other questions? Right. Okay. So again,
I am just add a quick something. First of all, thanks very much for delivering this presentation. That was incredibly clear and eloquent and as usual. My name is Jeff Brown, everybody, and I'm responsible for everything that is not to do with the content of the program. At the moment, we are running a discount for those who want to enroll onto the program, which is 20%. And that discount is available until the 26th of April, so next week, end of next week. For those of you who've got any other questions that you want to ask about this program, here is my email address in the chat. And so feel free to ask any questions in the coming hours, days, and so on. And again, thanks very much for attending, and hopefully look forward to having you on the program.